Hi, I've written a question similar to number 11 in your workbook, Unit 5. And this is about completing a reaction and identifying it as being a redox or not a redox. So here's the question that I wrote. Complete and balance, explain why this reaction is or is not a redox reaction. And then I added this afterward. Identify the species oxidized or reduced and the oxidizing or reducing agent. So if you examine the reactants here, you should see that this is a potential single replacement reaction. In order for it to be a good reaction, magnesium would need to be above chromium on the activity series for metals. So here's magnesium and here's chromium. Because the free element is above the metal. So first of all, the replacing species is a metal. It will replace the other metal. And if the free metal is above the metal in the compound, then it's a good reaction. So magnesium that wants to enter the compound is indeed above chromium, and the reaction occurs. So then using your periodic table to check charges on ions and polyatomic ions, you need to write the correct products. Magnesium will go with nitrate, but when you check magnesium, it's a 2 positive, and nitrate is a 1 negative. So we know the correct formula would be MgNO3 bracket 2. And then it's necessary to check your solubility rules, and you would see that all nitrates are soluble. So you know you have a soluble product. And you have the chromium, and the element is, of course, a solid, which you can check in the periodic table as well. Now we need to balance the reaction. We see the most complicated part here is we have 3 nitrates on one side and 2 on the other. Our multiple for 3 and 2 would be 6. I'm going to need 3 in front of here to give me 6 nitrates, balancing them as a group, and 2 in front of here. Then I will also need a 2 here and a 3 here to complete my balancing. Now that we have completed and balanced the equation, we're ready to get to the redox part. So why is this, or why is it not a redox reaction? In order to prove an answer here, although we know that most of the time redox reactions are everything other than a double displacement, that's not actually proof. Proof would be to assign oxidation numbers to every atom within a compound, to every atom on each side of the equation. And if we see anything change, it's redox, and if nothing changes, it isn't. So following our rules for assigning oxidation numbers, magnesium is 0. It's an element here, so it has a 0 oxidation number. Chromium would be the same as a charge on the ion, and here from the fact that it takes 3 nitrates to balance it, we know that this is a chromium 3 positive, so a +3 oxidation number. Within the nitrate, oxygen is its usual oxidation number of -2 because it's not with fluorine and it's not in a peroxide. And then if we figure out that the residual charge on a nitrate is 1 negative, we know that the nitrogen would have to be +5 in order for the nitrogen, and 3 oxygens, 3 times -2 is -6. We need -1 left over for the ion charge. The only thing nitrate could be, nitrogen in the nitrate could be, is +5. So a little bit quicker on the other side, magnesium is a +2, its ion charge. The nitrogen and oxygen in the nitrate don't change. Same numbers for same reason. And chromium is an element, so it's 0. So we see here that chromium has changed and magnesium has changed. So Magnesium has its oxidation number increase, so magnesium is oxidized, and is the reducing agent. The chromium has its oxidation number decrease, so chromium is reduced and is the oxidizing agent. We weren't asked for more information, but we could have easily said that because of oil rig, oxidation is lost. The one that is oxidized loses electrons. Or has its oxidation number increase. The chromium reduction is gain, so this one gains electrons. Or has its oxidation number decrease. So that's 8 possible questions based on that one reaction. In the second reaction, it's set up as a possible double displacement. And I know it's not an acid-base neutralization, so it's probably a precipitate formation if it occurs. So I know that this copper is with chloride. It takes 2 chloride to balance it, although the copper could be a 1 or a 2 positive. This one has to be the 2 positive. So if the copper goes with the carbonate, and carbonate is a 2 negative, I know that the correct formula is CuCO3. And the sodium goes with the chloride, and when I check their charges, 1 positive and 1 negative, the formula is NaCl. When I balance this, I'm going to need a 2 here. And if you want to fill in the ones, 1 in front of everything else will balance the equation. Now I need to use my solubility rules. I know that chlorides are usually soluble compounds. Sodium is not an exception, so this is soluble. And that carbonates are only soluble with group 1 and ammonium, and otherwise most carbonates are insoluble. So because my carbonate is in the insoluble section and not an exception, I write ester solid. And because chlorides are soluble, I write AQ up here. When I assign oxidation numbers in this reaction, we'll use my ion charges. I have +2, -1 for each chloride, +1 for the sodium, -2 for the oxygen. Again, it's not an exception. It's not with fluorine, and it's not in a peroxide. It's in a carbonate. So the carbon would have to be +4 in order for 3 oxygens at -2 each, giving me -6. In order to end up with a 2 negative ion charge, the carbon would have to be +4 to cancel 4 of those 6 charges and leave a residual charge of 2 negative. On the other side, copper is +2. Carbonate is exactly the same, so +4, -2, +1 for sodium ion, -1 for chloride ion, and we see no oxidation numbers changing. So one thing I forgot to answer directly up here, this reaction is a redox. This one is not a redox. And the reason, no oxidation numbers changed. So again, expect that double displacements will usually not be redox reactions, but the proof is in assigning oxidation numbers and proving whether they do or do not change. If any oxidation number changes, like in this example, it is a redox, and all of our other reaction types, combination, decomposition, single and double replacement, these are, combination, decomposition, single replacement, and hydrocarbon combustion. These usually are redox. And double displacements usually are not. Now, I think I need a coffee before I shoot the next video because there are quite a lot of fumbles there. Perhaps a little caffeine. Anyway, go try some similar problems in your workbook now.